number systems and more specifically how we categorize numbers. Please follow along, listen. Remember, you can pause this video at any moment to think about what I've just said, rewind it, and be ready to kind of think your way through this. So let's go ahead and start. We always put our names on the top of our papers. All right, so a decimal expansion. A decimal expansion is how a number is written out in decimal form, showing all the digits after the decimal point. For example, the decimal expansion of 1/2 is 0.5, and the decimal expansion for 1/3 is 0.33333333. We would write that like this, 0.3 repeating. Okay, all real numbers have a decimal expansion. So as you look at this set of numbers here, okay, every one of these numbers has a decimal expansion. Okay, no matter what it is, we use a calculator to find the decimal expansion. So this would be a good point right now to pause the video and go over to my Schoology page and open up the Desmos Scientific Calculator. It is linked right in the top of my Schoology page. So we are going to create decimal expansions. The reason why we create decimal expansions is it helps us order numbers, place them on number lines, and decide whether or not they are rational or irrational. So we're going to talk about that here in a minute. So remember, decimal expansion, these are two of kind of our vocab words. When you're thinking about the word expansion, expansion means to make longer. So we are taking a number and expanding its decimals. So this first one is kind of silly here as we look at it. 72. Well, I mean, 72 has a decimal expansion, 72.0. As does -41, -41.0. So those are the decimal expansions for those numbers. Yeah, it kind of seems silly to write that out, but later it is going to help us remember whether or not a number is rational or irrational. So let's go ahead and look at this next one, 17/20. This is where I'm going to switch over to my calculator, and our beloved Desmos calculator, 17/20. We'll turn this into a decimal. So there on the right side, you can see the decimal expansion for the fraction. So when we have a fraction, if we want to know the decimal expansion, we simply type it in and it gives it to us. So our decimal expansion for 17/20 is 0.85. Let's do the same thing for 7/11. So let's go back to our calculator, 7/11. So that's kind of a funky number there, 0.63636363. And do you see that 4 at the end if you're looking closely? That's just rounding because the Desmos calculator can only give us so many digits. So what we're seeing here under 7/11 is 0.636363 and so on. And how we write that is 0.63 repeating with a line over both the 6 and the 3 because they're both repeating. So there's a pattern there, and we'll talk about that here in a minute. Our next number is the square root of 7. Okay, so this is something we're going to talk about more. Square root undoes square. We will talk about that in the next video a little bit more, but here we'll just kind of see what that is. So the square root of 7. So if you look on the left side under the word main, there's this little kind of checkmarky looking thing. If you hit that, it brings up the square root, and then you put a 7, and it goes ahead and gives us the decimal expansion, 2.645751311. So no real pattern there. We're just going to kind of write out the first 4 digits. So 2.64575, 2.64575, and then I'm just going to kind of let it trail with those 3 little dots. Okay, and what that means is this goes on, but there is no pattern here. So we could round this to about 2.65, but it is not an exact value. Here, This 0.63 repeating, that's an exact value. We know exactly what that is. This little about sign means we have rounded this number. Does not mean that the decimal terminates. We're going to talk about that in a little bit. The decimal goes on forever, but then we can round that to approximate the value of the square root of 7. All right, pi. There's a pi button. Okay, it's right to the 2 buttons to the right of the first one we hit. If we hit pi, 3.14159,265, and so on. So this is also a number that has a decimal expansion with no repeat. 3.1435 ... We round that to about 3.14. All right, so that is how we create a decimal expansion. We go to our calculator, we type it in, our calculator gives it to us, and then we kind of interpret that. All right, now, there are types of decimal expansions. So, decimal expansions can do the following 3 things. They can terminate. Think about the word terminate. Terminate means end. Okay? They can repeat. What does repeat mean? Repeat means there's a pattern. And then they can do neither. And we'll talk about that as well. They can do neither. They can neither repeat nor terminate. Okay, so let me give you a few examples here. So a terminating decimal would be like 3.7 or 17.1 or negative 3.0. Those are all terminating decimals. The decimal is ended. I should give more examples. 2.753. That terminates. 0.6123. That also terminates. It ends. A repeating decimal would be like 7.2222. You might see those little dots after it. Well, this equals 7.2 repeating. Or you might see something like this. 0.123, 123, 123, and so on. We can abbreviate that, or we can kind of rewrite that as 0.123 with a line over all 3 things. You talked about that as 7th graders, repeating versus terminating decimals. All right, examples of neither repeating nor terminating. Okay? So 1.231754 and so on. I just made that up. There's no pattern there. There's no repetition. It just keeps going on. Another beautiful example is pi, 3.14159, so on. There is no pattern. There is no termination. It goes on forever. All right, so hit a quick pause. Give yourself a quick thought about that. 3 types of decimal expansions: terminating, repeating, and neither terminating nor repeating. All right, let's go ahead and look at this. Here are some examples of what are called rational numbers. So we have 2 types of numbers we're going to talk about: rational and irrational. So rational numbers, okay? Rational numbers are all numbers whose decimals expansions terminates or repeats, okay? And then there's this cool fact about all rational numbers can be written as fractions, okay? Decimal expansions of rational numbers are exact. So there are 7 different types of numbers over here that we might see that all fall into rational numbers. We have positive whole numbers, negative whole numbers, any positive or negative fraction, because a positive or negative fraction will have decimal expansions that terminate or repeat. So here we also can have repeating decimals. Those turn into fractions, terminating decimals, or mixed numbers. So as we summarize this, we have whole numbers, fractions, we have terminating or repeating decimals. Okay? So whole numbers, Fractions, remember it's also positive or negative whole numbers. Fractions, terminating or repeating decimals. Those 4 types of numbers will be rational. All right, irrational numbers. Let's flip over to the next page. Irrational numbers are all numbers whose decimal expansions neither terminate nor repeat. Irrational numbers cannot be written as fractions. We see these in a couple of ways. Square roots, cube roots. Again, don't worry too much about that today, but we're going to talk about that. Numbers like pi and just random non-repeating decimals. So these are we're going to see these most as square roots in our class and pi and cube roots. Okay? And then other non-repeating decimals. Okay? All decimal expansions of irrational numbers are approximate. They're approximate because they go on forever. We don't actually know what's coming after that. Our calculator approximates it for us, but it goes on forever and ever and ever. All right. So, to review, we've talked about rational numbers. We've talked about irrational numbers. Okay? And what we can do is we can take their decimal expansions and order them from least to greatest. Okay? So, I'm going to go ahead and write down of these 5 numbers we have. 1, 2, 3, 4, 5. I'm going to go ahead and highlight the rational numbers. Fraction, that one is a terminating decimal, and this one's a terminating decimal. So, I'm just going to go ahead and over here, I'm going to write and sort my rational numbers. Okay, we have 0.5, 3.5, and negative 7/8. I'm going to go to my calculator, and I am going to take that negative 7/8 and make it a decimal. Negative 0.875. Negative 0.875. Then our irrational numbers. Okay, irrational numbers are the negative square root of 3 and the square root of 5. Okay, so let's go ahead and make these into decimals. The negative square root of 3, negative 1.73. And we're going to put that dot, dot, dot out there. And then square root of 5 will be 2.236. So we're going to write this as 2.24. Actually, I'm just going to do this. 236 and so on. So now we can go ahead and once we have all 5 of these numbers into decimals, we can go ahead and pick what's the smallest decimal. So our smallest decimal is when we're dealing with negative numbers, remember it's actually the biggest negative number is the smallest number. So we're going to end up there with starting our smallest number is going to be negative radical 3. Our next smallest number is our other negative number, which is going to be negative 7/8. Our next smallest number is going to be 0.5, followed by radical 5, because it's 2. And then our largest number is 3.5. So what we've done here, we have identified our numbers as rational and irrational. We have changed our numbers into their decimal expansions. From their decimal expansions, we can go ahead and order them from smallest to largest. Okay, now, we're going to take each of these following numbers and we're going to place them on the number line. So 5 halves. I'm going to start with that. 5 halves is a fraction. So this number I can go ahead and turn into a decimal. 5 divided by 2 is 2.5. That decimal terminates. Therefore, it's rational. I'm just going to use an R. So I can now go ahead and place this on the number line. 2.5 is going to be between 2 and 3. Okay, we can go ahead and estimate that to the best of our abilities. So I'm going to put that right here, 2.5. So that is where we're going to locate 5 halves. My next number is 0.75. 0.75 is a decimal that terminates. So I automatically know that that's rational without any effort. So 0.75 is going to lie between 0 and 1. So I'm going to go ahead and I'm going to put that here, but closer to 1 than 0, but it's going to sit right there. All right, negative pi is our next number. So I'm going to go ahead and write that down. I'm going to go to my calculator, turn that into a decimal. The negative pi, or the opposite of pi, is negative 3.14. So it's about negative 3.14. So therefore, it is irrational. Okay, so I'm going to go a little bit to the left of 3, and we're going to estimate its location, negative pi. So my next number is negative 2/3. So negative 2/3 is going to be, if I type this in my calculator, negative 2 divided by 3 is negative 0.6 repeating. So this equals negative, I'm going to erase that, that's a little sloppy, 0.6 repeating. Since it's a repeating decimal, it is a rational number. So I'm going to go to my calculator, or to my number line, go just to the left of 0, almost all the way to negative 1. And I'm going to put that here, negative 2/3. And then my final number is the square root of 7. Again, we use our calculators to estimate the location of square roots. So I'm going to go square root of 7 gives me 2.65, about 2.65. That is a irrational number. So I'm going to go ahead and place that. 2.65 is bigger than 2.65 is larger than 2.5. So it's going to need to go just to the right side of that. So I'm going to write it down here, square root of 7. All right, you've watched the entire video. You've taken notes. Let's go back. I know this is a little long. This is a lot of information. I'm going to continue to talk about this day after day. So all numbers have decimal expansions, okay? Decimal expansions can either terminate, meaning end, repeat, meaning pattern, or do neither. Based on that, we can classify numbers into rational or irrational. So the best way to do this is make a number into a decimal. If it terminates or repeats, it's rational. That means it can be written as a fraction. If it does neither terminates nor repeats, meaning it's a weird square root or a pi or a number like that, then it is irrational. We can then order and compare numbers based on decimal expansions. Again, thank you for following along.